Problem number 45, evaluate this double integral. The first thing that we should realize is that we're being asked to find the antiderivative of sine of x squared with respect to x, like the insight integral is asking us to do. That's going to be a very difficult proposition. So how do we handle this? Let's reverse the order integration and see if integrating with respect to y first and then with respect to x makes our life easier, and then see if we can evaluate that new double integral. So in order to do this, let's figure out what the bounds currently are. Y is going from 0 to 1, and x is going from y to 1. And so this is going to be a triangle in the xy plane. Y ranges from 0 to 1. X, we have the line y is equal to x, and we have the line x is equal to 1. And so this right here is the triangle in question, because y runs from 0 to 1, and for a particular fixed value of y, x runs from the line x is equal to y, which is y is equal to x is equal to 1. So if we want to do this going in the other order, we need to slice this vertically, not horizontally. Here we see x runs from 0 to 1, and y runs from 0 to x. So now, what do we end up with? We end up with the integral, the double integral. X runs from 0 to 1, y runs from 0 to x. Sine of x squared, dy dx. And realize this, what's going on here? We're integrating sine of x squared with respect to y now. And that's going to be a constant with respect to y. So antiderivative here of sine of x squared with respect to y is going to be y times sine of x squared. Plug in y is 0 and y is x. So when we plug in y is x, we just get x times sine of x squared. Plug in 0, we get 0, so minus 0. I'll just drop that term. And look at what happened here. Look at what happened. We now have, originally we try to find antiderivative of sine of x squared. We can't do that. That's too difficult for us. But now there's an extra factor of x out in front, and this is tailor-made for substitution. So we can substitute in u is equal to x squared, du is equal to 2x dx, or du over 2 is x dx. So this is u, and there's du over 2. So what do we have right now? Sine of u times du over 2. And u ranges from, when x is 0, u is 0. When x is 1, u is 1 squared is 1. And so we are integrating sine of u over 2 between 0 and 1. And our final answer then is going to be negative cosine of u over 2. Plug in 0 and 1. And so this ends up as negative cosine of 1 over 2 plus cosine of 0. What cosine of 0 is 1 plus 1/2. So that's how you do this type of problem. It didn't explicitly say to change the bounds here, but we should realize that this was too difficult of an antiderivative to define with respect to x. We change the order of the integration. Life becomes much more easy.